Now I can get the right window open. All right, there we go. Okay, so this is the Unit 1.4-ish handout, which will be stuff related to 1.4 problems. So let me get a marker here. Okay, so first there were some definitions at the top of the page, and we've done a couple of these in class briefly, like the definition of subset I think we did, where A is a subset of B really means if X is an element of A, then X must be an element of B. And union, you can say A union B means if X is in A or X is in B, then X has to be in the union. And you can also use the converse of that. Union, intersection, complement, or union and intersection, you can essentially use the either or. You can use if A then B and if B then A. They're essentially definitions, so they work both ways. Okay, so intersection has the same sort of deal, but it's and instead of or. And then complement has two kinds of definitions, essentially. It also works both ways. If X is in the complement of A, then X is not in A. Or it also means if X is not in A, then X must be in the complement. Okay, so we're going to use these and some of our tautology stuff from 1.3 to try to do a set theory proof. Okay, it's an if and only if proof, which means you really have to prove two things in if and only if. So if you're trying to prove P if and only if Q, then really what you need to do is prove if P then Q and if Q then P. And then you can conclude that, so in order to prove this, you'd have to do this one and this one. And then you could conclude, therefore, P if and only if Q. Okay, so first, we're trying to prove if this, then that, right? So in order to do that, you first assume the if that you're trying to prove. Why is this not letting me write? Okay, so let me see, we got to assume it. So let A intersect B equal A, right? That's a given. We're assuming it. Okay, we want to prove that this is true. The way you prove A is a subset of B is you pick an element in A, right? Let little a, or whatever letter you want to call it, be an A. Okay, well I know A equals A intersect B. For A must be an A intersect B. That's actually a substitution step. Okay? Well, if A is in A intersect B, and I know that the intersection definition says then A must be in capital A or A must be in capital B, go to this. A must be in A, and A must be in B. That's because of the definition of intersection. Okay. Well, I know A has to be in A and A has to be in B, then I know A has to be in B. This is if you have P and Q, then you have Q. That's this law of simplification, which I think is like 2C or something. Okay, well I started then with if A is in A, then A is in B. Well, that means that A is a subset of B because this rule. If something's in A and something's in B, that means you have a subset. Okay? So, definition of subset. Okay. So then we've said, okay, therefore, if A intersect B equals A, then A is a subset of B. That's what we've just proven here. We started with this, and we ended with this. Okay, so part one is done. Part two, we're trying to prove this thing. So we've got to let A be a subset of B given. We're assuming that the if part is true. We're trying to conclude this. This is annoying because in order to show A intersect B equals A, you need to show two parts. So part 2A would be to show A intersect B is a subset of A, and part 2B would be to show A is a subset of intersect B. Okay. All right. So let's do A. Let's show A intersect B is a subset of A. So we're going to let, I'll call it X this time. Let X be an element in A intersect B. Okay. And then we want to show then that X has to be an A. So therefore X has to be an element of A and X has to be an element of B. That's the definition of intersection. Well, that means that X has to be an A because that's the law of simplification. So if X is in this, then X has to be in that. That means intersect B has to be a subset of A. That's definition of subset. All right, so that's part 2A. Now we need part 2B, which is show the opposite. Show that A is a subset of A intersect B. Okay, so let A, sorry, let me erase that. There we go. So I'm going to say, let's let X be in the first set now. Okay. Now we want to show that X has to be in the second set. Okay, so let's see, what can we say here? Oh, we have this given way up here, right? So if X is in A, and A is a subset of B, X has to be in B, right? Because that's the definition of subset. I'm going to add in a little note for myself because A is a subset was given. Just because it was given so long ago, it's kind of confusing if you don't put it there. Okay. Let's see. Well, X is in A then, and X is in B. And X is in B. That's actually given one as well, because we have both of them. Well, actually, I don't know. It's not really given, I suppose. It's from previous two steps, let's say. I don't think there's any tautology on that chart that says if you have A and you have B, then you have A and B. So we'll just, we can call that the duh rule. Okay, so if X is in A and X is in B, then X has to be in A intersect B. That's the definition of intersection. So now, since X was in A led us to X is in A intersect B, we know that A is a subset of A intersect B. Definition of subset. Okay, so from parts 2A and 2B, we know that A has to equal A intersect B. Okay, because one's a subset of the other and the other is a subset of the first. This is actually definition of set quality. It's if you can prove that each is a subset of the other, then the sets are equal. So that's how you define set equality. Okay, And so all that tells us if A is a subset of B, then A equals intersect B. Okay? So there's really one last thing you have to write from parts 1 and 2. We can conclude that A intersect B equals A if and only if A is a subset of B, because we proved if this then that, and if that then this. Okay. You could say that this is I don't remember what rule it is off the top of my head, but it's if P goes to Q and if Q goes to P, then let's see, how was this written? I think it's something like this. Then that means you have that. P if and only if Q. This is probably listed as a biconditional topology as well. So I want to say it's like 1-ish. I can't remember. I don't know, but it's in the 1 column somewhere, I'm pretty sure. Okay, I hope that helps a little bit, and you can use some of these ideas in your homework coming up soon. All right, take care, and I hope to see you soon. Oh, I have no way of stopping the video.